Item 340. Dense graded hot mix asphalt, small quantity. 1. Description. Construct a hot mix asphalt, HMA, pavement layer composed of a compacted, dense graded mixture of aggregate and asphalt binder mixed hot in a mixing plant. This specification is intended for small quantity, SQ, HMA projects, typically under 5,000 tons total production. 2. Materials. Furnish uncontaminated materials of uniform quality that meet the requirements of the plans and specifications. Notify the engineer of all material sources and before changing any material source or formulation. The engineer will verify that the specification requirements are met when the contractor makes a source or formulation change, and may require a new laboratory mixture design, trial batch, or both. The engineer may sample and test project materials at any time during the project to verify specification compliance in accordance with Item 6, Control of Materials. 2.1 Aggregate. Furnish aggregates from sources that conform to the requirements shown in Table 1 and as specified in this section. Aggregate requirements in this section, including those shown in Table 1, may be modified or eliminated when shown on the plans. Additional aggregate requirements may be specified when shown on the plans. Provide aggregate stockpiles that meet the definitions in this section for coarse, intermediate, or fine aggregate. Aggregate from reclaimed asphalt pavement, RAP, is not required to meet Table 1 requirements unless otherwise shown on the plans. Supply aggregates that meet the definitions in Tex 100E for crushed gravel or crushed stone. The engineer will designate the plant or the quarry as the sampling location. Provide samples from materials produced for the project. The engineer will establish the surface aggregate classification, SAC, and perform Los Angeles abrasion, magnesium sulfate soundness, and microdeval tests. Perform all other aggregate quality tests listed in Table 1. Document all test results on the mixture design report. The engineer may perform tests on independent or split samples to verify contractor test results. Stockpile aggregates for each source and type separately. Determine aggregate gradations for mixture design and production testing based on the washed sieve analysis given in Text 200F, Part 2. 2.1.1 Coarse aggregate. Coarse aggregate stockpiles must have no more than 20% material passing the number 8 sieve. Aggregates from sources listed in the department's Bituminous Rated Source Quality Catalog, BRSQC, are pre-approved for use. Use only the rated values for hot mix listed in the BRSQC. Rated values for surface treatment, ST, do not apply to coarse aggregate sources used in hot mix asphalt. For sources not listed on the department's BRSQC, build an individual stockpile for each material. Request the department test the stockpile for specification compliance, and, once approved, do not add material to the stockpile unless otherwise approved. Provide aggregate from non-listed sources only when tested by the engineer and approved before use. Allow 30 calendar days for the engineer to sample, test, and report results for non-listed sources. Provide coarse aggregate with at least the minimum SAC shown on the plans. SAC requirements only apply to aggregates used on the surface of travel lanes. SAC requirements apply to aggregates used on surfaces other than travel lanes when shown on the plans. The SAC for sources on the department's Aggregate Quality Monitoring Program, AQMP, Tex 499A, is listed in the BRSQC. 2.1.1.1 Blending Class A and Class B aggregates. Class B aggregate meeting all other requirements in table may first be blended with a Class A aggregate to meet requirements for Class A materials. Ensure that at least 50% by weight, or volume if required, of the material retained on the number 4 sieve comes from the Class A aggregate source when blending Class A and B aggregates to meet a Class A requirement. Blend by volume if the bulk specific gravities of the Class A and B aggregates differ by more than 0.300. Coarse aggregate from RAP and recycled asphalt shingles, RAS, will be considered as Class B aggregate for blending purposes. The engineer may perform tests at any time during production, when the contractor blends Class A and B aggregates to meet a Class A requirement, to ensure that at least 50% by weight, or volume if required, of the material retained on the number 4 sieve comes from the Class A aggregate source. The engineer will use the department's mix design template, when electing to verify conformance, to calculate the percent of Class A aggregate retained on the number 4 sieve by inputting the bin percentages shown from readouts in the control room at the time of production and stockpile gradations measured at the time of production. The engineer may determine the gradations based on either washed or dry sieve analysis from samples obtained from individual aggregate cold feed bins or aggregate stockpiles. The engineer may perform spot checks using the gradations supplied by the contractor on the mixture design report as an input for the template. However, a failing spot check will require confirmation with a stockpile gradation determined by the engineer. 2.1.2 Intermediate aggregate. Aggregates not meeting the definition of coarse or fine aggregate will be defined as intermediate aggregate. Supply intermediate aggregates, when used, that are free from organic impurities. The engineer may test the intermediate aggregate in accordance with TEX 408A to verify the material is free from organic impurities. Supply intermediate aggregate from coarse aggregate sources, when used, that meet the requirements shown in Table 1 unless otherwise approved. Test the stockpile if 10% or more of the stockpile is retained on the number 4 sieve, and verify that it meets the requirements in Table 1 for crushed face count, TEX 460A, and flat and elongated particles, TEX 280F. 2.1.3 Fine aggregate. Fine aggregates consist of manufactured sands, screenings, and field sands. Fine aggregate stockpiles must meet the gradation requirements in Table 2. Supply fine aggregates that are free from organic impurities. The engineer may test the fine aggregate in accordance with TEX 408A to verify the material is free from organic impurities. No more than 15% of the total aggregate may be field sand or other uncrushed fine aggregate. Use fine aggregate, with the exception of field sand, from coarse aggregate sources that meet the requirements shown in Table 1 unless otherwise approved. Test the stockpile if 10% or more of the stockpile is retained on the number 4 sieve, and verify that it meets the requirements in Table 1 for crushed face count, TEX 460A, and flat and elongated particles, TEX 280F. Table 1. Aggregate quality requirements. See table in specifications. 1. Not used for acceptance purposes. Optional test used by the engineer as an indicator of the need for further investigation. 2. Only applies to crushed gravel. 3. Aggregates, without mineral filler, RAP, RAS, or additives, combined as used in the job mix formula, JMF. Table 2. Gradation requirements for fine aggregate. Sieve size and percent passing by weight or volume. Sieve size 3/8 with 100% passing. Sieve size number 8 with 70 to 100% passing. Sieve size number 200 with 0 to 30% passing. 2.2 Mineral filler. Mineral filler consists of finely divided mineral matter such as agricultural lime, crusher fines, hydrated lime, or fly ash. Mineral filler is allowed unless otherwise shown on the plans. Use no more than 2% hydrated lime or fly ash unless otherwise shown on the plans. Use no more than 1% hydrated lime if a substitute binder is used unless otherwise shown on the plans or allowed. Test all mineral fillers except hydrated lime and fly ash in accordance with TEX 107E to ensure specification compliance. The plans may require or disallow specific mineral fillers. Provide mineral filler, when used, that is sufficiently dry, free-flowing, and free from clumps and foreign matter as determined by the engineer. Does not exceed 3% linear shrinkage when tested in accordance with TEX 107E, and meets the gradation requirements in Table 3. Table 3. Gradation requirements for mineral filler. Sieve size and percent passing by weight or volume. Sieve size number 8 with 100% passing. Sieve size number 200 with 55 to 100% passing. 2.3 Bagus fines. Fines collected by the bagus or other dust collecting equipment may be reintroduced into the mixing drum. 2.4 Asphalt binder. Furnish the type and grade of performance graded, PG, asphalt specified on the plans. 2.5 TAC code. Furnish CSS1H, SS1H, or a PG binder with a minimum high temperature grade of PG 58 for TAC code binder in accordance with item 300, asphalts, oils, and emulsions. Specialized or preferred TAC code materials may be allowed or required when shown on the plans. Do not dilute emulsified asphalts at the terminal, in the field, or at any other location before use. The engineer will obtain at least one sample of the TAC code binder per project in accordance with TEX 500C, Part 3, and test it to verify compliance with item 300, asphalts, oils, and emulsions. The engineer will obtain the sample from the asphalt distributor immediately before use. 2.6 Additives. Use the type and rate of additives specified when shown on the plans. Additives that facilitate mixing, compaction, or improve the quality of the mixture are allowed when approved. Provide the engineer with documentation, such as the bill of lading, showing the quantity of additives used in the project unless otherwise directed. 2.6.1 Lime and liquid anti-stripping agent. When lime or a liquid anti-stripping agent is used, add in accordance with item 301, asphalt anti-stripping agents. Do not add lime directly into the mixing drum of any plant where lime is removed through the exhaust stream unless the plant has a bagus or dust collection system that reintroduces the lime into the drum. 2.6.2 Warm mix asphalt, WMA. Warm mix asphalt, WMA, is defined as HMA that is produced within a target temperature discharge range of 215 degrees Fahrenheit and 275 degrees Fahrenheit using approved WMA additives or processes from the department's MPL. WMA is allowed for use on all projects and is required when shown on the plans. When WMA is required, the maximum placement or target discharge temperature for WMA will be set at a value below 275 degrees Fahrenheit. Department-approved WMA additives or processes may be used to facilitate mixing and compaction of HMA produced at target discharge temperatures above 275 degrees Fahrenheit, however, such mixtures will not be defined as WMA. 2.7 Recycled materials. Use of RAP and RAS is permitted unless otherwise shown on the plans. Do not exceed the maximum allowable percentages of RAP and RAS shown in Table 4. The allowable percentages shown in Table May 4 be decreased or increased when shown on the plans. Determine asphalt binder content and gradation of the RAP and RAS stockpiles for mixture design purposes in accordance with TEX 236F. The engineer may verify the asphalt binder content of the stockpiles at any time during production. Perform other tests on RAP and RAS when shown on the plans. Asphalt binder from RAP and RAS is designated as recycled asphalt binder. Calculate and ensure that the ratio of the recycled asphalt binder to total binder does not exceed the percentages shown in Table 5 during mixture design and HMA production when RAP or RAS is used. Use a separate cold feed bin for each stockpile of RAP and RAS during HMA production. Surface, intermediate, and base mixes referenced in Tables 4 and 5 are defined as follows. Surface. The final HMA lift placed at or near the top of the pavement structure. Intermediate. Mixtures placed below an HMA surface mix and less than or equal to 8.0 inches from the riding surface, and base. Mixtures placed greater than 8.0 inches from the riding surface. 2.7.1 RAP. RAP is salvaged, milled, pulverized, broken, or crushed asphalt pavement. Crush or break RAP so that 100% of the particles pass the 2 inches. Sieve. Fractionated RAP is defined as 2 or more RAP stockpiles, divided into coarse and fine fractions. Use of contractor-owned RAP, including HMA plant waste, is permitted unless otherwise shown on the plans. Department-owned RAP stockpiles are available for the contractor's use when the stockpile locations are shown on the plans. If department-owned RAP is available for the contractor's use, the contractor may use contractor-owned fractionated RAP and replace it with an equal quantity of department-owned RAP. This allowance does not apply to a contractor using unfractionated RAP. Department-owned RAP generated through required work on the contract is available for the contractor's use when shown on the plans. Perform any necessary tests to ensure contractor or department-owned RAP is appropriate for use. The department will not perform any tests or assume any liability for the quality of the department-owned RAP unless otherwise shown on the plans. The contractor will retain ownership of RAP generated on the project when shown on the plans. The coarse RAP stockpile will contain only material retained by processing over a 3/8 inches or half an inch screen unless otherwise approved. The fine RAP stockpile will contain only material passing the 3/8 inches or half an inch screen unless otherwise approved. The engineer may allow the contractor to use an alternate to the 3/8 inches or half an inch screen to fractionate the RAP. The maximum percentages of fractionated RAP may be comprised of coarse or fine fractionated RAP or the combination of both coarse and fine fractionated RAP. Do not use department or contractor-owned RAP contaminated with dirt or other objectionable materials. Do not use department or contractor-owned RAP if the decantation value exceeds 5% and the plasticity index is greater than 8. Test the stockpiled RAP for decantation in accordance with TEX 406A. Part I. Determine the plasticity index in accordance with TEX 106E if the decantation value exceeds 5%. The decantation and plasticity index requirements do not apply to RAP samples with asphalt removed by extraction or ignition. Do not intermingle contractor-owned RAP stockpiles with department-owned RAP stockpiles. Remove unused contractor-owned RAP material from the project site upon completion of the project. Return unused department-owned RAP to the designated stockpile location. Table 4. Maximum allowable amounts of RAP. See table in specifications. One must also meet the recycled binder to total binder ratio shown in Table 5. 2 up to 5% RAS may be used separately or as a replacement for fractionated RAP. 3 unfractionated RAP may not be combined with fractionated RAP or RAS. 2.7.2 RAS. Use of post-manufactured RAS or post-consumer RAS, tear-offs, is permitted unless otherwise shown on the plans. Up to 5% RAS may be used separately or as a replacement for fractionated RAP in accordance with Table 4 and Table 5. RAS is defined as processed asphalt shingle material from manufacturing of asphalt roofing shingles or from re-roofing residential structures. Post-manufactured RAS is processed manufacturer's shingle scrap byproduct. Post-consumer RAS is processed shingle scrap removed from residential structures. Comply with all regulatory requirements stipulated for RAS by the TCEQ. RAS may be used separately or in conjunction with RAP. Process the RAS by ambient grinding or granulating such that 100% of the particles pass the 3/8 inches. Sieve when tested in accordance with TEX 200F. Part I. Perform a sieve analysis on processed RAS material before extraction, or ignition, of the asphalt binder. Add sand meeting the requirements of Table 1 and Table 2 or fine RAP to RAS stockpiles if needed to keep the processed material workable. Any stockpile that contains RAS will be considered a RAS stockpile and be limited to no more than 5% of the HMA mixture in accordance with Table 4. Certify compliance of the RAS with DMS 11000, evaluating and using non-hazardous recyclable materials guidelines. Treat RAS as an established non-hazardous recyclable material if it has not come into contact with any hazardous materials. Use RAS from shingle sources on the department's MPL. Remove substantially all materials before use that are not part of the shingle, such as wood, paper, metal, plastic, and felt paper. Determine the deleterious content of RAS material for mixture design purposes in accordance with Text 217F, Part 3. Do not use RAS if deleterious materials are more than 0.5% of the stockpiled RAS unless otherwise approved. Submit a sample for approval before submitting the mixture design. The department will perform the testing for deleterious material of RAS to determine specification compliance. 2.8 Substitute binders. Unless otherwise shown on the plans, the contractor may use a substitute PG binder listed in Table 5 instead of the PG binder originally specified, if the substitute PG binder and mixture made with the substitute PG binder meet the following. The substitute binder meets the specification requirements for the substitute binder grade in accordance with Section 300.2.10, Performance Graded Binders, and the mixture has less than 10.0 mm of rutting on the Hamburg wheel test, Text 242F, after the number of passes required for the originally specified binder. Use of substitute PG binders may only be allowed at the discretion of the engineer if the Hamburg wheel test results are between 10.0 mm and 12.5 mm. Table 5. Allowable substitute PG binders and maximum recycled binder ratios. See table in specifications. 1. Combined recycled binder from RAP and RAS. 2. Use no more than 20% recycled binder when using this originally specified PG binder. 3. WMA as defined in Section 340.2.6.2, Warm Mix Asphalt, WMA, DOT. 4. When used with WMA, this originally specified PG binder is allowed for use at the maximum recycled binder ratios shown in this table. 3. Equipment. Provide required or necessary equipment in accordance with Item 320, Equipment for Asphalt Concrete Pavement. 4. Construction. Produce, haul, place, and compact the specified paving mixture. In addition to tests required by the specification, contractors may perform other QC tests as deemed necessary. At any time during the project, the engineer may perform production and placement tests as deemed necessary in accordance with Item 5, Control of the work. Schedule and participate in a pre-paving meeting with the engineer on or before the first day of paving unless otherwise directed. 4.1 Certification. Personnel certified by the department-approved hot mix asphalt certification program must conduct all mixture designs, sampling, and testing in accordance with Table 6. Supply the engineer with a list of certified personnel and copies of their current certificates before beginning production and when personnel changes are made. Provide a mixture design developed and signed by a Level 2 certified specialist. Table 6. Test methods, test responsibility, and minimum certification levels. See table in specifications. 1 Level 1A, 1B, and 2 are certification levels provided by the Hot Mix Asphalt Center Certification Program. 2 Voids in mineral aggregates. 3 Refer to Section 340.4.8.3, Production Testing, for exceptions to using an ignition oven. 4 Profiler and operator are required to be certified at the Texas A&M Transportation Institute facility when surface test type B is specified. 4.2 Reporting, testing, and responsibilities. Use department-provided templates to record and calculate all test data pertaining to the mixture design. The engineer will use department templates for any production and placement testing. Obtain the current version of the templates at http://www.txdot.gov/inside-forms-consultants-forms-site-manager.html or from the engineer. The maximum allowable time for the engineer to exchange test data with the contractor is as given in Table 7 unless otherwise approved. The engineer will immediately report to the contractor any test result that requires suspension of production or placement or that fails to meet the specification requirements. Subsequent mix placed after test results are available to the contractor, which require suspension of operations, may be considered unauthorized work. Unauthorized work will be accepted or rejected at the discretion of the engineer in accordance with Article 5.3, conformity with plans, specifications, and special provisions. Table 7. Reporting schedule. See table in specifications. 1-2 days are allowed if cores cannot be dried to constant weight within 1 day. 4.3 Mixture design. 4.3.1 Design requirements. The contractor may design the mixture using a Texas gyratory compactor, TGC, or a superpave gyratory compactor, SGC, unless otherwise shown on the plans. Use the dense graded design procedure provided in Text 204F. Design the mixture to meet the requirements listed in Tables 1, 2, 3, 4, 5, 8, 9, and 10. 4.3.1.1 Target laboratory molded density when the TGC is used. Design the mixture at a 96.5% target laboratory molded density. Increase the target laboratory molded density to 97% or 97.5% at the contractor's discretion or when shown on the plans or specification. 4.3.1.2 Design number of gyrations, and design, when the SGC is used. Design the mixture at 50 gyrations, and design. Use a target laboratory molded density of 96% to design the mixture. However, adjustments can be made to the end design value as noted in Table 9. The end design level may be reduced to no less than 35 gyrations at the contractor's discretion. Use an approved laboratory from the department's MPL to perform the Hamburg wheel test in accordance with Text 242F, and provide results with the mixture design, or provide the laboratory mixture and request that the department perform the Hamburg wheel test. The engineer will be allowed 10 working days to provide the contractor with Hamburg wheel test results on the laboratory mixture design. The engineer will provide the mixture design when shown on the plans. The contractor may submit a new mixture design at any time during the project. The engineer will verify and approve all mixture designs, JMF1, before the contractor can begin production. Provide the engineer with a mixture design report using the department-provided template. Include the following items in the report: the combined aggregate gradation, source, specific gravity, and percent of each material used. Asphalt binder content and aggregate gradation of RAP and RAS stockpiles. The target laboratory molded density, or end design level when using the SGC. Results of all applicable tests. The mixing and molding temperatures. The signature of the Level 2 person or persons that performed the design. The date the mixture design was performed, and a unique identification number for the mixture design. Table 8. Master gradation limits, percent passing by weight or volume, and VMA requirements. See table in specifications. 1. Defined as maximum sieve size. No tolerance allowed. Table 9. Laboratory mixture design properties. See table in specifications. 1. Increase to 97% or 97.5% at the contractor's discretion or when shown on the plans or specification. 2. Adjust within a range of 35 to 100 gyrations when shown on the plans or specification or when mutually agreed between the engineer and contractor. 3. The engineer may allow the IDT strength to exceed 200 psi if the corresponding Hamburg wheel rut depth is greater than 3.0 mm and less than 12.5 mm. 4. Used to establish baseline for comparison to production results. May be waived when approved. Table 10. Hamburg wheel test requirements. See table in specifications. 1. When the rut depth at the required minimum number of passes is less than 3 mm, the engineer may require the contractor to increase the target laboratory molded density, TGC, by 0.5% to no more than 97.5% or lower the end design level, SGC, to no less than 35 gyrations. May 2nd be decreased to no less than 5,000 passes when shown on the plans. May 3rd be decreased to no less than 10,000 passes when shown on the plans. 4.3.2 Job Mix Formula Approval. The Job Mix Formula, JMF, is the combined aggregate gradation, target laboratory molded density, or end design level, and target asphalt percentage used to establish target values for hot mix production. JMF1 is the original laboratory mixture design used to produce the trial batch. When WMA is used, JMF1 may be designed and submitted to the engineer without including the WMA additive. When WMA is used, document the additive or process used and recommended rate on the JMF1 submittal. Furnish a mix design report, JMF1, with representative samples of all component materials and request approval to produce the trial batch. Provide approximately 10,000 g of the design mixture and request that the department perform the Hamburg wheel test if opting to have the department perform the test. The engineer will verify JMF1 based on plant-produced mixture from the trial batch unless otherwise determined. The engineer may accept an existing mixture design previously used on a department project and may waive the trial batch to verify JMF1. Provide split samples of the mixtures and blank samples used to determine the ignition oven correction factors. The engineer will determine the aggregate and asphalt correction factors from the ignition oven used for production testing in accordance with TEX 236F. The engineer will use a TGC calibrated in accordance with TEX 914K in molding production samples. Provide an SGC at the engineer's field laboratory for use in molding production samples if the SGC is used to design the mix. The engineer may perform TEX 530C and retain the tested sample for comparison purposes during production. The engineer may waive the requirement for the boil test. 4.3.3 JMF Adjustments. If JMF adjustments are necessary to achieve the specified requirements, the adjusted JMF must be provided to the engineer in writing before the start of a new lot. Be numbered in sequence to the previous JMF. Meet the mixture requirements in Table 4 and Table 5. Meet the master gradation limits shown in Table 8, and be within the operational tolerances of the current JMF listed in Table 11. The engineer may adjust the asphalt binder content to maintain desirable laboratory density near the optimum value while achieving other mix requirements. Table 11. Operational tolerances. See table in specifications. 1. When within these tolerances, mixture production gradations may fall outside the master grading limits. However, the percent passing the number 200 will be considered out of tolerance when outside the master grading limits. 2. Only applies to mixture produced for Lot 1 and higher. 3. Mixture is required to meet Table 8 requirements. 4.4 Production Operations. Perform a new trial batch when the plant or plant location is changed. Take corrective action and receive approval to proceed after any production suspension for non-compliance to the specification. Submit a new mix design and perform a new trial batch when the asphalt binder content of any wrap stockpile used in the mix is more than 0.5% higher than the value shown on the mixture design report, or RAS stockpile used in the mix is more than 2% higher than the value shown on the mixture design report. 4.4.1 Storage and heating of materials. Do not heat the asphalt binder above the temperatures specified in Item 300, asphalts, oils, and emulsions, or outside the manufacturer's recommended values. Provide the engineer with daily records of asphalt binder and hot mix asphalt discharge temperatures, in legible and discernible increments, in accordance with Item 320, Equipment for Asphalt Concrete Pavement, unless otherwise directed. Do not store mixture for a period long enough to affect the quality of the mixture, nor in any case longer than 12 HR unless otherwise approved. 4.4.2 Mixing and discharge of materials. Notify the engineer of the target discharge temperature and produce the mixture within 25 degrees Fahrenheit of the target. Monitor the temperature of the material in the truck before shipping to ensure that it does not exceed 350 degrees Fahrenheit, or 275 degrees Fahrenheit for WMA, and is not lower than 215 degrees Fahrenheit. The department will not pay for or allow placement of any mixture produced above 350 degrees Fahrenheit. Produce WMA within the target discharge temperature range of 215 degrees Fahrenheit and 275 degrees Fahrenheit when WMA is required. Take corrective action any time the discharge temperature of the WMA exceeds the target discharge range. The engineer may suspend production operations if the contractor's corrective action is not successful at controlling the production temperature within the target discharge range. Note that when WMA is produced, it may be necessary to adjust burners to ensure complete combustion such that no burner fuel residue remains in the mixture. Control the mixing time and temperature so that substantially all moisture is removed from the mixture before discharging from the plant. The engineer may determine the moisture content by oven drying in accordance with Text 212F, Part 2, and verify that the mixture contains no more than 0.2% of moisture by weight. The engineer will obtain the sample immediately after discharging the mixture into the truck, and will perform the test promptly. 4.5 Hauling operations. Clean all truck beds before use to ensure that mixture is not contaminated. Use a release agent shown on the department's MPL to coat the inside bed of the truck when necessary. Use equipment for hauling as defined in Section 340.4.6.3.2, Hauling equipment. Use other hauling equipment only when allowed. 4.6 Placement operations. Collect haul tickets from each load of mixture delivered to the project and provide the department's copy to the engineer approximately every hour, or as directed. Use a handheld thermal camera or infrared thermometer to measure and record the internal temperature of the mixture as discharged from the truck or material transfer device, MTD, before or as the mix enters the paver, and an approximate station number or GPS coordinates on each ticket unless otherwise directed. Calculate the daily yield and cumulative yield for the specified lift and provide to the engineer at the end of paving operations for each day unless otherwise directed. The engineer may suspend production if the contractor fails to produce and provide haul tickets and yield calculations by the end of paving operations for each day. Prepare the surface by removing raised pavement markers and objectionable materials such as moisture, dirt, sand, leaves, and other loose impediments from the surface before placing mixture. Remove vegetation from pavement edges. Place the mixture to meet the typical section requirements and produce a smooth, finished surface with a uniform appearance and texture. Offset longitudinal joints of successive courses of hot mix by at least 6 inches. Place mixture so that longitudinal joints on the surface course coincide with lane lines, or as directed. Ensure that all finished surfaces will drain properly. Place the mixture at the rate or thickness shown on the plans. The engineer will use the guidelines in Table 12 to determine the compacted lift thickness of each layer when multiple lifts are required. The thickness determined is based on the rate of 1/10 pound/square yard for each inch of pavement unless otherwise shown on the plans. Table 12. Compacted lift thickness and required core height. See table in specifications. 4.6.1 Weather conditions. Place mixture when the roadway surface temperature is at or above 60 degrees Fahrenheit unless otherwise approved. Measure the roadway surface temperature with a handheld thermal camera or infrared thermometer. The engineer may allow mixture placement to begin before the roadway surface reaches the required temperature if conditions are such that the roadway surface will reach the required temperature within 2 hr of beginning placement operations. Place mixtures only when weather conditions and moisture conditions of the roadway surface are suitable as determined by the engineer. The engineer may restrict the contractor from paving if the ambient temperature is likely to drop below 32 degrees Fahrenheit within 12 hr of paving. 4.6.2 Tack coat. Clean the surface before placing the tack coat. The engineer will set the rate between 0.04 and 0.10 gal of residual asphalt per square yard of surface area. Apply a uniform tack coat at the specified rate unless otherwise directed. Apply the tack coat in a uniform manner to avoid streaks and other irregular patterns. Apply a thin, uniform tack coat to all contact surfaces of curbs, structures, and all joints. Allow adequate time for emulsion to break completely before placing any material. Prevent splattering of tack coat when placed adjacent to curb, gutter, and structures. Roll the tack coat with a pneumatic tire roller to remove streaks and other irregular patterns when directed. 4.6.3 Laydown operations. 4.6.3.1 Windrow operations. Operate windrow pickup equipment so that when hot mix is placed in windrows, substantially all the mixture deposited on the roadbed is picked up and loaded into the paver. 4.6.3.2 Hauling equipment. Use belly dumps, live bottom, or end dump trucks to haul and transfer mixture. However, with exception of paving miscellaneous areas, end dump trucks are only allowed when used in conjunction with an MTD with remixing capability unless otherwise allowed. 4.6.3.3 Screed heaters. Turn off screed heaters, to prevent overheating of the mat, if the paver stops for more than 5 minutes. 4.7 Compaction. Compact the pavement uniformly to contain between 3.8% and 8.5% in-place air voids. Furnish the type, size, and number of rollers required for compaction as approved. Use a pneumatic tire roller to seal the surface unless excessive pickup of fines occurs. Use additional rollers as required to remove any roller marks. Use only water or an approved release agent on rollers, tamps, and other compaction equipment unless otherwise directed. Use the control strip method shown in Text 207F, Part 4, on the first day of production to establish the rolling pattern that will produce the desired in-place air voids unless otherwise directed. Use tamps to thoroughly compact the edges of the pavement along curbs, headers, and similar structures and in locations that will not allow thorough compaction with rollers. The engineer may require rolling with a trench roller on widened areas, in trenches, and in other limited areas. Complete all compaction operations before the pavement temperature drops below 160 degrees Fahrenheit unless otherwise allowed. The engineer may allow compaction with a light finish roller operated in static mode for pavement temperatures below 160 degrees Fahrenheit. Allow the compacted pavement to cool to 160 degrees Fahrenheit or lower before opening to traffic unless otherwise directed. Sprinkle the finished mat with water or lime water, when directed, to expedite opening the roadway to traffic. 4.8 Production acceptance. 4.8.1 Production lot. Each day of production is defined as a production lot. Lots will be sequentially numbered and correspond to each new day of production. Note that lots are not subdivided into sublots for this specification. 4.8.2 Production sampling. 4.8.2.1 Mixture sampling. The engineer may obtain mixture samples in accordance with Text 222F at any time during production. 4.8.2.2 Asphalt binder sampling. The engineer may obtain or require the contractor to obtain 1 QT samples of the asphalt binder at any time during production from a port located immediately upstream from the mixing drum or pug mill in accordance with Text 500C, Part 2. The engineer may test any of the asphalt binder samples to verify compliance with Item 300, asphalts, oils, and emulsions. 4.8.3 Production testing. The engineer will test at the frequency listed in the department's guide schedule of sampling and testing and the specification. The engineer may suspend production if production tests do not meet specifications or are not within operational tolerances listed in Table 11. Take immediate corrective action if the engineer's laboratory molded density on any sample is less than 95% or greater than 98%, to bring the mixture within these tolerances. The engineer may suspend operations if the contractor's corrective actions do not produce acceptable results. The engineer will allow production to resume when the proposed corrective action is likely to yield acceptable results. The engineer may use alternate methods for determining the asphalt binder content and aggregate gradation if the aggregate mineralogy is such that Text 236F does not yield reliable results. Use the applicable test procedure if an alternate test method is selected. Table 13. Production and placement testing. See table in specifications. 1. Testing performed by the construction division or designated laboratory. 4.8.3.1 Voids in mineral aggregates, VMA. The engineer may determine the VMA for any production lot. Take immediate corrective action if the VMA value for any lot is less than the minimum VMA requirement for production listed in Table 8. Suspend production and shipment of the mixture if the engineer's VMA result is more than 0.5% below the minimum VMA requirement for production listed in Table 8. In addition to suspending production, the engineer may require removal and replacement or may allow the lot to be left in place without payment. 4.8.3.2 Hamburg Wheel Test. The engineer may perform a Hamburg wheel test at any time during production, including when the boil test indicates a change in quality from the materials submitted for JMF1. In addition to testing production samples, the engineer may obtain cores and perform Hamburg wheel tests on any areas of the roadway where rutting is observed. Suspend production until further Hamburg wheel tests meet the specified values when the production or core samples fail the Hamburg wheel test criteria in Table 10. Core samples, if taken, will be obtained from the center of the finished mat or other areas excluding the vehicle wheel paths. The engineer may require up to the entire lot of any mixture failing the Hamburg wheel test to be removed and replaced at the contractor's expense. If the department's or department-approved laboratory's Hamburg wheel test results in a remove and replace condition, the contractor may request that the department confirm the results by retesting the failing material. The construction division will perform the Hamburg wheel tests and determine the final disposition of the material in question based on the department's test results. 4.8.4 Individual loads of hot mix. The engineer can reject individual truckloads of hot mix. When a load of hot mix is rejected for reasons other than temperature, contamination, or excessive uncoated particles, the contractor may request that the rejected load be tested. Make this request within 4 HR of rejection. The engineer will sample and test the mixture. If test results are within the operational tolerances shown in Table 11, payment will be made for the load. If test results are not within operational tolerances, no payment will be made for the load. 4.9 Placement Acceptance. 4.9.1 Placement Lot. A placement lot is defined as the area placed during a production lot, 1 day's production. Placement lot numbers will correspond with production lot numbers. 4.9.2 Miscellaneous areas. Miscellaneous areas include areas that typically involve significant handwork or discontinuous paving operations, such as temporary detours, driveways, mailbox turnouts, crossovers, gores, spot level-up areas, and other similar areas. Miscellaneous areas also include level UPS and thin overlays when the layer thickness specified on the plans is less than the minimum untrimmed core height eligible for testing shown in Table 12. The specified layer thickness is based on the rate of 110 pounds/square yard for each inch of pavement unless another rate is shown on the plans. Compact miscellaneous areas in accordance with Section 340.4.7, Compaction. Miscellaneous areas are not subject to in-place air void determination except for temporary detours when shown on the plans. 4.9.3 Placement Sampling. Provide the equipment and means to obtain and trim roadway cores on site. On site is defined as in close proximity to where the cores are taken. Obtain the cores within 1 working day of the time the placement lot is completed unless otherwise approved. Obtain 2 6 inches diameter cores side by side at each location selected by the engineer for in-place air void determination unless otherwise shown on the plans. For Type D and Type F mixtures, 4 inches diameter cores are allowed. Mark the cores for identification, measure, and record the untrimmed core height, and provide the information to the engineer. The engineer will witness the coring operation and measurement of the core thickness. Visually inspect each core and verify that the current paving layer is bonded to the underlying layer. Take corrective action if an adequate bond does not exist between the current and underlying layer to ensure that an adequate bond will be achieved during subsequent placement operations. Trim the cores immediately after obtaining the cores from the roadway in accordance with Text 207F if the core heights meet the minimum untrimmed value listed in Table 12. Trim the cores on site in the presence of the engineer. Use a permanent marker or paint pen to record the date and lot number on each core as well as the designation as Core A or B. The engineer may require additional information to be marked on the core and may choose to sign or initial the core. The engineer will take custody of the cores immediately after they are trimmed and will retain custody of the cores until the department's testing is completed. Before turning the trimmed cores over to the engineer, the contractor may wrap the trimmed cores or secure them in a manner that will reduce the risk of possible damage occurring during transport by the engineer. After testing, the engineer will return the cores to the contractor. The engineer may have the cores transported back to the department's laboratory at the HMA plant via the contractor's haul truck or other designated vehicle. In such cases where the cores will be out of the engineer's possession during transport, the engineer will use department-provided security bags and the roadway core custody protocol located at http://www.txdot.gov/business/specifications.htm to provide a secure means and process that protects the integrity of the cores during transport. Instead of the contractor trimming the cores on site immediately after coring, the engineer and the contractor may mutually agree to have the trimming operations performed at an alternate location such as a field laboratory or other similar location. In such cases, the engineer will take possession of the cores immediately after they are obtained from the roadway and will retain custody of the cores until testing is completed. Either the department or contractor representative may perform trimming of the cores. The engineer will witness all trimming operations in cases where the contractor representative performs the trimming operation. Dry the core holes and tack the sides and bottom immediately after obtaining the cores. Fill the hole with the same type of mixture and properly compact the mixture. Repair core holes with other methods when approved. 4.9.4 Placement Testing. The engineer may measure in-place air voids at any time during the project to verify specification compliance. 4.9.4.1 In-place air voids. The engineer will measure in-place air voids in accordance with Text 207F and Text 227F. Cores not meeting the height requirements in Table 12 will not be tested. Before drying to a constant weight, cores may be pre-dried using a corelock or similar vacuum device to remove excess moisture. The engineer will use the corresponding theoretical maximum specific gravity to determine the air void content of each core. The engineer will use the average air void content of the two cores to determine the in-place air voids at the selected location. The engineer will use the vacuum method to seal the core if required by Text 207F. The engineer will use the test results from the unsealed core if the sealed core yields a higher specific gravity than the unsealed core. After determining the in-place air void content, the engineer will return the cores and provide test results to the contractor. Take immediate corrective action when the in-place air voids exceed the range of 3.8% and 8.5% to bring the operation within these tolerances. The engineer may suspend operations or require removal and replacement if the in-place air voids are less than 2.7% or greater than 9.9%. The engineer will allow paving to resume when the proposed corrective action is likely to yield between 3.8% and 8.5% in-place air voids. Areas defined in Section 340.9.2, miscellaneous areas, are not subject to in-place air void determination. 4.9.5 Irregularities. Identify and correct irregularities including segregation, rutting, raveling, flushing, fat spots, matte slippage, irregular color, irregular texture, roller marks, tears, gouges, streaks, uncoated aggregate particles, or broken aggregate particles. The engineer may also identify irregularities, and in such cases, the engineer will promptly notify the contractor. If the engineer determines that the irregularity will adversely affect pavement performance, the engineer may require the contractor to remove and replace, at the contractor's expense, areas of the pavement that contain irregularities and areas where the mixture does not bond to the existing pavement. If irregularities are detected, the engineer may require the contractor to immediately suspend operations or may allow the contractor to continue operations for no more than 1 day while the contractor is taking appropriate corrective action. 4.9.6 Ride Quality. Use surface test type A to evaluate ride quality in accordance with item 585, ride quality for pavement surfaces, unless otherwise shown on the plans. 5. Measurement. Hot mix will be measured by the ton of composite hot mix, which includes asphalt, aggregate, and additives. Measure the weight on scales in accordance with item 520, weighing and measuring equipment. 6. Payment. The work performed and materials furnished in accordance with this item and measured as provided under Article 340.5, measurement, will be paid for at the unit bid price for dense graded hot mix asphalt, SQ, of the mixture type, sack, and binder specified. These prices are full compensation for surface preparation, materials including tack coat, placement, equipment, labor, tools, and incidentals. Trial batches will not be paid for unless they are included in pavement work approved by the department. Payment adjustment for ride quality, if applicable, will be determined in accordance with item 585, ride quality for pavement surfaces.